Okay, now we come to the relationship between the alpha and beta, right? So we know what is alpha. This is the DC current gain in a common base mode, and beta is what? This is the DC current gain in a common emitter mode. So before we move on to that, we will understand how is IC given by. This IC expression is very much similar to that of a current components of a transistor. That also I've given a video lecture. If you have forgotten, then please go through that video once. Then if the emitter is forward biased, then IC is given by IC is equals to IC. ICO is what? The reverse saturation current, right? So IC is basically what? IC should be basically the reverse saturation current that is flowing between the base collector junction, right? But IC is basically the summation of the reverse saturation current and the current which is coming from the emitter side, because collector is a section where it accepts something, right? But actually the current that what a collector current should be is only the reverse saturation current. So what we have done is that IC is equals to the reverse saturation current minus the current that is coming from the emitter side, right? And this alpha is the gain. This alpha is the gain due to the early effect, right? So whatever gain that is coming from the emitters, whatever gain that is coming from the base side alpha, and whatever holes that are coming from the emitter side, that is IE, is all being subtracted. So whatever that is now left is only the reverse saturation current which is happening due to the reverse bias in the collector base junction, right? From this we have to just obtain IE, which is IE equal to ICO minus IC whole divided by alpha. So we have kept this as equation 1. Now we have to apply the KCL law or Kirchhoff current law in the PNP transistor. If you observe PNP transistor, the current direction that I have given in my video lectures, from that if you observe, then it is the emitter current which is entering into the transistor, and it is the collector and the base current which is moving outside the transistor. In KCL we know that the one which is entering a particular junction has to be considered positive, and the one that is moving out of the particular junction has to be considered negative. So IE is equal to negative times of IC plus IB, right? So this is also a IE equation. This is also an equation of IE. If I compare these two, then I can easily equate the RHS of these two equations, right? So that is what we have done. ICO minus IC whole divided by alpha equal to minus of IC plus IB. So now what we do is that we will first remove this negative sign. So for this we multiply the negative sign from both the sides. So if I do that, then I will this minus sign will be cancelled, and this will be IC minus ICO, and this alpha is then cross multiplied with this value, with the RHS value, which comes out to be alpha times of IC and alpha times of IB, right? Now what we do is that we take IC to the left hand side and we take IC common to get 1 minus alpha, and the remaining amount that is left is ICO will come to this side, and alpha times IB is also already present. Now with this configuration we will obtain IC is equals to ICO. This 1 minus alpha will be sent to RHS. So ICO by 1 minus alpha and alpha times IB, alpha divided by 1 minus alpha into IB is the one that is obtained in the RHS value. Now if I mark it as equation 3, now from this equation I will jump to another concept, and that is IB, which is the base current. Obviously the base current is much more that of the reverse saturation current. So obviously the term or the value that we will obtain from this section or from this term will be far less than what we will obtain from this term. So obviously we can easily ignore this term, and the remaining term that is left out is with this term only. That is, we have done IC is equal to alpha divided by 1 minus alpha into IB. Now I will take IB to this side, that is alpha by 1 minus alpha equal to IC by IB. Now we already know that beta is the ratio between the collector current and the base current, right? Beta is the DC current gain in a common emitter mode. So IC by IB can easily be replaced by beta. So the relationship that is established is beta equal to alpha by 1 minus alpha. We will try to put a slight modification in the equations that we have already done, that because it will help in solving our numerical problems, that we will have a direct formula to put the values into it, right? So what we do is that after we obtain beta equals to alpha by 1 minus alpha, we mark it as equation 4, and we add 1 to both sides of this equation. We get beta plus 1 and alpha by 1 minus alpha plus 1. We then simplify, we then take LCM between these two terms, and obviously alpha will get cancelled out, and we are left in the numerator with value of only 1, and in the denominator there will be only 1 minus alpha. So beta plus 1 equal to 1 minus alpha is the another kind of relation that we have established, and we mark it as equation 5. Then what we do is that we will basically put the values of these two equation obtained in this particular equation. What is this? See, if I take ICO away from, if I take ICO common, then I will be left with 1 by 1 minus alpha. Then 1 by 1 minus alpha is given by beta plus 1. So we have written beta plus 1 into ICO. And if I substitute alpha by 1 minus alpha with beta, then I will be left with beta into IB. Then it is beta into IB. So we obtain another kind of equation. IC is equals to beta plus 1 into ICO plus beta times of IB. So if you get a numerical problem where you get the beta or the DC current gain in the common emitter mode, as well as they give you the value of ICO, and you don't know how to solve this, then this equation will help you to solve. So from this equation, we can easily solve some very complex numerical problems by putting the values directly into this equation, and we'll get the answer. So while we discuss the numerical problems, we will not be discussing how this equation is obtained. So I'm discussing the equation derivation in this section itself. So I hope you have understood the relationship between beta and alpha, and don't forget to subscribe my channel, like and share among with your friends. Thank you.